And we need to find f inverse of x. So we need to find the inverse function. So this has a few steps, like to replace f of x with y. They're the same thing. I feel like it just makes it a little bit easier to see the swap, which is next. Next, we swap x and y, because that's how you find an inverse. We swap x and y, and then we want to take that new kind of equation and solve for y. And then once we've done that, we just kind of want to write it in the correct notation. We'll replace y with f inverse. This particular one with the fractions is a little more challenging because we're going to end up with variables in numerators and denominators, but it just involves a little creativity. Once you know how to do it, it gets easier with time. So first step, replace f of x with y. So instead of f of x equals 1x minus 3 over 3x plus 1, I'll say y equals 1x minus 3 over 3x plus 1. That's the first step. So we've already done the first step. Step 2 is swap x and y. So this becomes x equals 1y minus 3 over 3y plus 1. Now this is the challenging part. Step 3, solve for y. And this is because we have y in the numerator and denominator. So the thing I think would be helpful now is to just get rid of this fraction. So we're going to multiply both sides by 3y plus 1 so that it will cancel out on this side. And then we won't have that fraction over there. Now if we multiply by 3y plus 1 on the left, we must also multiply the right by 3y plus 1. Now on the right, on the left, we must multiply the left by 3y plus 1. So on the right side, it just cancels and reduces to a 1, so we can kind of ignore it there. And on the right, x times 3y is 3xy, and x times 1 is 1x. On the right, we just have 1y minus 3. This might not seem very helpful, but what we're going to do now is try to get these terms together because they both have a y. We're trying to solve for y. We're going to get those terms together, and we're going to get everything else away. And that way we can kind of pull that y out and solve for it. So let's get rid of this y term on the right side by subtracting 1y. And I don't know why I line it up under the 3xy. I can't actually collect those. They're not like terms. One has an xy and the other one just has a y. So I'm just going to kind of write them all together, I guess. 3xy minus 1y. I'll put it next to that term. Then plus 1x. On the right side, this is gone now. 1y minus 1y, that's 0. That's gone. And we just have this negative 3. So now let's get rid of this 1x term so that we'll have isolated our y terms. So we'll subtract 1x from both sides. And again, on the right, these are not like terms. I can't combine those either. On the left side, 1x minus 1x, that is 0 x's. It's gone over there. And what we're left with is 3xy minus 1y. On the right, you can write this in two ways. It's kind of better to have the x term first. So I might say minus 1x minus 3. But you could also say negative 3 minus 1x. They're equivalent. They're the same thing. So now that I have these two terms over here with the y, I'm going to factor out that y. I'm going to pull it out. We have a common factor of y. So I'm going to divide it out of those two terms. So what you're kind of doing, let's write this a little bit lower. If I'm pulling out y, when I write what is left, I'm actually taking these two terms and dividing that y out. And here's where it's going, right? So to find what's left, we're just going to reduce these. The first term becomes 3x because we pulled out that y into the front. And the second term, these reduce, but don't forget, it's kind of obvious here because we did show the coefficient of 1, this number right here. But if they do cancel out, remember they reduce to a 1, not a 0. Y over y is 1. So we get 1 here. And nothing's changed on the right. And we're almost done because we have y times 3x minus 1. And I know that seems like a lot, but I can just divide both sides by 3x minus 1. And that will reduce, that cancels to a 1. And now I just have y on the left side. On the right side, I have negative 1x minus 3 over 3x minus 1. And no matter how you write this, as tempting as it might be, do not cancel any of these. We cannot cancel things that are being added or subtracted to other things. So this is as nice as it gets, really. So that was the hardest step. I know that is several steps for these fractions. The very last thing we have to do is put this in the right notation. So instead of y, we're going to say f inverse of x equals negative 1x minus 3 over 3x minus 1. And there's our inverse function.